Incredible talks. Future of video is very bright and colorful thanks to AV1 and HDR. By the way, all puns intended there. And of course, very smooth and efficient thanks to content steering and AV1 there as well. Thanks, Bhumi, Chris, Ryan, and Will for these wonderful talks. Let's jump into questions. First of all, let's go over to you, Bhumi. Great talk on HDR on Android. I was curious, how compute intensive or even time intensive is it to tone map? And is all of it running on the server side? How much of it's running on the client side? Can you share any more details there?
Absolutely. So it's definitely compute and time intensive. Specifically when it comes to preview, we want to preview in real time, and we don't want any stuck videos, especially when the user is previewing, and we also have to tone map at the same time. The user is adding some effects. Those should be applied in real time as well. So we've had to go through definitely iterations. There are, it's a pros and cons to which kind of tone map algorithm you use, what kind of precision with which you are trying to tone map. And after iterations of, going through such regressions, we've finally been able to reach the point where we are able to do it in real time. And even on the upload side, we have been able to keep the latency in the same ballpark as the other SDR uploads. Definitely, it is like a learning, and then you just iterate on that.
That's awesome. I guess, Chris, you mentioned that you had to deal with certain tone map algorithms on the client side, particularly when you have thumbnails, because HDR thumbnails could look brighter than the other thumbnails, which are SDR. And in that scenario, I would guess that you have to do this for several thumbnails, several videos. So I was curious, how does that impact battery, CPU usage? Is that a concern when you have to tone map for thumbnail scenario?
Good question. So this actually all occurs on the GPU, so it's fairly lightweight. I'd say it's quite similar to what you might see in the editor as you're flipping through color filters, so very fast, real time. Plus, now that the screen's running at a lower brightness, because we're not doing HDR, you might even be saving on some battery.
Great, that's good to know. So are there other client-side tone mapping algorithms do you have to use? And I'm assuming those would be on the GPU as well?
Question for me or Bhumi?
Chris, we could stay on with you for this next question, since you mentioned the GPU is able to assist with some the client-side tone mapping algorithms. Are there others that besides the thumbnail ones that you have to also contend for GPU resources on the device side?
Yeah, so we basically just have one algorithm, and it tends to mirror what you might see if you also ask the Apple API for the default SDR color properties. And we do use it in a couple other places. So it also makes an appearance during our creation flow. So sometimes you might want to mix HDR and SDR content, whether it's for adding creative effects, or maybe you want to stitch between different sources. Some are HDR, some are SDR. And it's actually much more straightforward to drop in a filter that does the tone mapping, and you can toggle it on and off as you need, rather than having to restart the decoder to request SDR.
Okay, makes sense. Bhumi, back to you. I was wondering if there are any codec implications for tone mapping. Is it codec intensive, or it's dependent on any codec, or is it completely ignorant of whatever codec you might be using?
Yeah, so HDR transcode does definitely have dependencies on codecs, as I mentioned. On the other hand, tone mapping, since we completely handle it in the shader, it currently doesn't have any implications, because we are actually doing all the work after the decoding has happened and before the encoding. So we kind of handle it at that point. So currently it is the same dependencies as any SDR codec. But yeah, in future, absolutely, when we want to HDR transcode, we would have to use the codec that supports it.
Okay, great. Thank you. What sort of considerations you have to keep in mind, and how do you end up selecting a tone map algorithm? Are there any concerns that you have to watch out for, or what sort of inputs do you take?
Yeah, definitely. So as we mentioned, compute and time intensive is one of the main things. We want to make sure that we keep uploads still reliable and not increase latency, etc. One of the other big concerns that we also look at is what you see is what you get. So we want to make sure that we have various stages in our pipeline where we have to tone map. So for example, we tone map during preview, we tone map during transcode and upload. And if we actually managed to not tone map and maybe upload as HDR in case of like raw uploads, and let's say the user did not add any effects, then we might have to tone map on the server as well to handle it during playback on devices that actually do not support playback in HDR. So there are various levels in our pipeline where we would tone map, and at every level, we want to preserve what you see is what you get. So we want to make sure the user has a seamless experience when they previewed their video, when they added any effect, when they uploaded their video, when their friends saw their video, and during playback also. So we try to keep it the same in the client, in the server, so that it ends up looking the same in playback as well. And then there are, different challenges on the client as compared to server. You have a lot more tools that are available, but on the client, you have limited tools that you can actually use. So that is one of the major concerns as well, that we want to maintain that and preserve that what you see, what you get. Last thing you want to see is the user saw something, and then when their video uploaded, it looked very different. Yeah.
True. Yeah, you don't want that to happen. So was there any specific tone map algorithm that worked out well in practice?
So we started with basic algorithms like Reinhardt, tone map, and then we have iterated on them to get like the best results, which are very which preserve the colors really well. And the one that we use right now is the recommendation from ITUR, which is like considered as a good documentation on videos recommendations in general. And then we currently use the tone map approach from there, and that has worked out well. Yeah.
Awesome. Thank you. I guess we should move to Ryan. Couple of AV1 questions. Hey, Ryan, one question comes up often is what sort of adoption we are seeing with AV1 for live, or let's say even RTC? Are we still quite far away from it? And what sort of challenges remain there? It looks like we're getting good adoption for VOD. I was curious how you feel about live and RTC use cases, and what challenges remain there?
Yeah, that's a very good question. I think you probably already know that Google already enabled AV1 in their RTC use cases. And from Meta internal, our remote presence team is also experimenting that for their RTC usages. And from a codec point of view, like AV1 has very great coding tools and features for RTC usages, such as reference frame scaling and super resolution, which allows you to adjust the encoding resolution to adapt to the network bandwidth without sending a keyframe. And also the screen content coding tools can encode the screen content at a very low bitrate. That's very good for desktop and screen content sharing. So I think for us, the major challenge is still we are basically our main targeted devices is mobile phones. So at this stage, we have to integrate both the software encoder and decoder into the mobile phone and doing encoding and decoding at the same time. So we don't have any problem with PC and desktop. So I would say at this stage, the performance of the software AV1 encoder and decoder on mobile phone is still the major challenge we are facing. Yeah.
Great, thanks. I was curious about the SVT algorithm, which can you tell us more about the SVT AV1 kind of preset? Which one are we using that in production? Is that if that's something you're able to share?
Yeah, so the TLDR is that we currently don't use a fixed encoding preset. So as I mentioned in the talk, like SVT AV1 has 13 up to 13 preset, which allows you to pick performance versus quality trade-off point. So, but when we start the AV1 production, we carefully experiment with different preset. At the same time, we have to compare with our existing VP9 encoding families. So we want to make sure we deliver the expected, quality or coding efficiency improvement over the existing VP9. So we tuned carefully to use different preset for high resolution video because it's relatively easy to change to get the very big bitrate saving for high resolution video, but it's not so easy for lower resolution video and low bitrate video. So we have to use higher quality preset for lower resolution and the lower bitrate video. So kind of to a nutshell, we don't kind of use a fixed preset. At the same time, we also work very closely with Intel to continue improve the SVT1 coding efficiency and the compute efficiency. All those latest improvements are already kind of landed in SVT1 and released it through the SVT1 release process. So all the entire community can actually benefit from that. So another point I want to make is kind of moving forward, we also want to do kind of more system level optimization, use a higher level and cost and benefit model, basically to control the overall compute based on the predicted watch time and the bitrate saving and the encoding cost for each individual video, and then decide whether we should use VP9 or AV1 or even AVC for particular video. So that will be kind of a more system level optimization opportunities for us.
Makes sense. Are there any, besides quality, any encoding, like other configurations that we have to watch out for, that you have to think about on the server side? Are there trade-offs between quality, let's say performance, or any other configuration that you have to keep in mind?
Yeah, I think besides the encoding preset, which kind of dominantly decide the quality and the performance, another unique feature I also mentioned in the talk is that the fast decode option, which is introduced in SVT1, which designed specifically to help us to speed up the decoding process. Because at this stage, we still don't have like a hardware decoder widely available. So this feature can help us to improve the playback and the decoding speed. Another thing we also fine-tuned is the number of threads to use, because that controls not only the performance, but also the amount of memory footprint and the bandwidth you use on the backend server side. So we have to carefully tune it to kind of limit the number of threads to use for each encoding instance to make sure we don't get into this out of memory problem on the backend server.
There was a question live about a SPY paper on LCEVC and SVT AV1. If you haven't checked it out, Ryan, if you want to check it out, we can come back to it if you have any comments on that, while we can go and chat with Will. Hey, Will, great demo, by the way. It was good to see how seamless the transition was from one CDN to the other, thanks to the steering spec. So I was curious, player adoption, is there thoughts being put towards accelerating the adoption with the players? And typically, what do you expect, how long this would take to get all the Dash players adopt the new spec?
So yeah, it's always, anytime you introduce a new feature, it's a chicken or egg problem. The players say, well, why should I do the work? There's no content to steer. And the content distributors go, well, there's no players to steer my content, so I'm not going to steer anything. So obviously we run into this problem every time we add a new feature. So within Dash Industry Forum, we seed new features in our own reference player, which is Dash.js. And this is used in a lot of production cases, as well as being a reference for how it should be done. So the content steering is already in there, and that's the player I was using for those demos. But then after that, beyond that, clearly what we typically do is find a content distributor. And we did this with Paramount, who were very good for CMCD distribution. They went ahead and put the changes into Shaka Player, into, in that case, HLS.js. So we find a content distributor who wants to steer, and then have the code base, the steering added to the other open source players. And then finally to the constrained players like the Bitmovings or the Theo players, then finally Exoplayer, because that's pretty dominant in the Android space. But it will not be instant. The answer to how long will it take is several years until all, in fact, will all Dash players support it? Probably never. But will the right enough Dash players support it so where it becomes useful for a business? That will depend upon the number and diversity of players that you have, and whether you're using mainline players that other people have already done the work to build the support in for it.
Okay, so until that happens, are there any thoughts or strategies on how to support the older players? So if there's a new decorated manifest with the new spec, handed over to older player, how would that react? And what sort of work is
so the spec is backwards compatible. You can give, it's a new element, right? And the player should ignore XML elements that are well formatted, but that it doesn't need to understand or parse. So older players just won't do anything. They will do their normal failover, and they will do the best they can to play content. So they won't be steerable. And they're still playing content for the end user though. So it depends if your goal is general moving players, you can look at the fraction of players that would support it or wouldn't support it in your cohort, and then you would know pretty precisely how many you can steer and how many you can't. And if that passes the threshold, yes, you'll go ahead and steer them, or you'll wait until the player support gets to the level where it makes a meaningful difference for your distribution scheme.
That's great. An interesting question came up in live. Ingestion path, are there any similar specs or strategies to manage this besides on the delivery path, the ingestion path as well?
So MPEG Dash is a distribution format, to be clear. Now you do sometimes ingest it into a CDN, but when like Akamai, for example, you can post Dash to us, but we have a spec for how you post it to us. And there's Dash Industry Forum has a ingest spec that I think does specify failover, but it's a very different mechanism to the steering that's being done here. It's typically a failover mode, or it's often a retry mode as well. Try, what's your back off and your retry? Do you send all data? When do you give up posting data? So content steering, the short answer to the question, it's really focused on distribution. And there may or may not be similar schemes on the ingest side, and there may or may not be more focused on failover than steering, because it's a far more constrained free for decisions.
Yep. That was a great question from Tan, and I believe it will be, it's a good problem. I think there's similar considerations on the ingestion side as well that need to be thought of. Another one that came from Shiv Kumar, he was wondering if it should be player-driven, the decision-making to change CDNs, or is it analytics or predictive analytics driven? I think maybe player is factoring that, but curious, well, what do you think about that?
That's a great question. It should be clearly analytics driven. You shouldn't be switching anything blindly, and you should be using data that's coming from the players in the wild. You shouldn't use beacons or timing objects. So what I really like is combining CMCD, which is structured player data that flows down from a player as it's requesting content down through all the CDNs. You collect that in real time from your players. It's got buffer length, it's got number of rebuffer sessions, and it's a much clearer picture of the player health. And then you use that as part of your analytics to go steer those players from one CDN to another by getting aggregate real-time metrics from the players. So I think combining CMCD with content steering makes a lot of sense. And remember, the player, as part of the spec, is also ascending along the throughput it's seeing from that CDN. So that's one aspect of it, but I think it can be enriched. And certainly CMCD gives you much richer data than simply the throughput alone.
All right, yeah, that makes a lot of sense. Another one, going to, again, steering spec, are there considerations of blacklisting? Like if there was service interruptions, is it player driven? Is this the service driven? And the second part of that question was, what if there are network issues?
So the player network issues are going to happen far faster than some content steering server sitting off on the side is going to be able to react to them. So the player needs to react. It's, as I mentioned in the talk, its primary job is provide good QoE for the end user. So if there's 4 CDNs that can use the last steering server response gave it 3 out of the 4 and it ranked them. So they were A, B, C, D, and it said you should use B, C, and D. And it's playing B like it was told, and there's a problem. It should fail out of that and then go try the other ones in the order that was prescribed, and hopefully find good quality on one of them. And then when it reports back to the content steerer, it reports back that it's playing a different CDN to the last one it was steered to. And that's a feedback loop to the content steering server that the player was unable to follow those instructions. So the player should be semi-autonomous. It should take these guidelines, but in the end, it's responsible for QoE for the end user.
Great, thank you so much. And sounds like we're at time. So we'll make that as the last question. Thanks so much again, Bhumi, Chris, Ryan, Will, for being part of this year's Video at Scale, for the incredible talks and answering these questions here. So that was the last session. There is a small closing note after this, but we will sign off from here, from the Live Center. And thanks for joining again today. See you all.
Thank you.